ओके गाइस, सो वेलकम टू लेक्चर नंबर 3। आज का हमारा एजेंडा क्या रहेगा? हम लोग जो है हमारा इंट्रोडक्टरी जो चैप्टर है उसी को कंटिन्यू रखेंगे। तो पिछले सो वी विल कीप कंटिन्यूइंग द लास्ट लेक्चर ओनली। वी वर डिस्कसिंग द इंट्रोडक्शन पार्ट. So in the last lecture we've talked a lot about histograms, and there were a few more pictorial methods that are there. So we will first discuss that, and then we will start to talk about all the what are different measures of location, mean, median, mode, all of these things. So we will discuss that, and then we will continue to see what are the different measures of variability. Okay, that is going to be the agenda for today. So let us start. Before we start, any doubts from the previous class? Anything?
No, ma'am.
Okay, chalo, very nice. Okay, so first of all, there is one more pictorial method that we have, which is called stem and leaf diagram. And then there is one which is called dot plots. So let's just, discuss them first. So what is a stem and leaf diagram? So first of all, when you have a lot of data, and this is one of the methods to represent the data. So let's say, for example, I have a data like this. So let's say, for example, so we are talking about stem and leaf diagram. Stem and leaf diagram. So let's say I have a data like this, which is, let's say, 26, 37, 48, 33, 49, 26, 19, 26, and then 48 again. So I am given a data like this, and I have to draw a stem and leaf diagram. So what are the steps involved in making a stem and leaf diagram? First of all, what do you have to do? You have to select one or more of the leading digit. Leading digit meaning the digit which comes in front. So here what we can see is that all the data that we have is of 2 digits, right? So 26, 37, 48, all of these things. So what are the leading digits that we have? So we have 2, we have 3, we have 4, we have 3, 4, 2, 1, 2, 4. So these are leading digits, okay? So what do you do? So you can take one or more leading digits, and then you can pick them up. They become your stem. So it's like, as the name is suggesting, stem and leaf. So like this is the stem, and from a stem, lot of leaves are coming, right? From a particular stem, lots of leaves are coming. So what you have to do is first you have to create a stem, and then you have to see what are the different leaves that are attached to that stem. So whenever you have to make such a diagram, you have to find what is the stem and then what are different leaves. So आपको क्या करना है? You have to do this. So there is something called stem, and then there is something called leaf. So whatever your leading digits are, the digits in front. So it could be, in this particular example, because it's a 2, all these are 2-digit numbers. So whatever is the second digit, they become your stem. So what are the different numbers that we have here? I have 1, and then I have 2, and then I have 3 also, and then I have 4 also, right? So what you do, just write all these in the column which is stem. So you can write 1 here, 2 here, 3, 4, and we don't see anything else. Okay, and then you have to list all these stems in a column which we have written, and then what do you have to do? In front of the stem, write all the numbers that are there as leaves. Okay, so what are the numbers that I have here? Here I have, so in front of 1, what else is there? 19. So I have a 9, and then that's all. So what I will do is I will write a 9 here. Okay, then in front of, like, after 2, so I have 3 numbers, 20, I have 26, again 26, again 26. So I have 6, 6, 6 3 times. So what I will do is I will write this 6, and then 6, and then 6. Okay, that's what I will do. Okay, now after that, in front of 3, whatever I have, so I have 37, 33, and that's all. So you here also you will write the numbers in ascending order. So you will write it like this: 3 and 7. And in front of 4, what do you have? 48, 49, and 48. So I have 8 two times, and then I have 9. So what you can do is you can make it like this: 8 and 8 and 9. This is your stem and leaf diagram. Okay. So, and one more thing that you have to do in front of whenever you make any stem and leaf diagram is you have to mention what is the stem and what are the leaves. So what is your stem? It is your 10th place digit, right? So at any place in this diagram, you have to write what is your stem and what are your leaves. So my stem is 10th the 10th place, right? And here this is the unit place. So you can write it like this. All right. And that is your stem and leaf diagram. So for every stem and leaf diagram, you will follow all these steps. So first you will figure out कि आपकी stem क्या है. Then you will figure out if in front of every single stem, what are the different leaves that are there. If some number is getting repeated, you keep writing it as many times as you want. So if, we saw that 26 is 3 times, so we will write 666. This indicates how many times it has come. Okay. So whenever you see any diagram like this, you can find what was your data. So 1, 9, 19 was one number, then 26 was number, and then again 26, and then again 26, and then 33, and then 37, and then 48, and then 48, and then 49. Okay. So that is what you have to do. Write leaves, and then just mention what was your stem and what was your leaf so that you can figure out whenever you're trying to figure out the data. Okay. Is that all right?
Ma'am, in case of 3-digit or 4-digit number, what will be the stem and leaf?
Yeah. So now let's take an example which has 3-digit numbers. Okay. So what you can do is, let's say I have data which is like this. So this is 523, 369, 700, 834, 95, 953, 366, 528. What you can do here is, tell me, what do you think you should be doing here? What can you do? Okay, also for decimal, definitely we'll do that. No worries. What will you do here? So we have to figure out what is stem and what is leaf. Okay. So I can do the following. I can do it like this also. So here I see that, what are the numbers that I have? I have 5, I have 3, I have 7, and then I have 8, and then I have 9, and then I have 3, and then I have 5 again, right? So what you can do is, whatever is your 100th place number, that can be your stem, and whatever numbers are there, they can act like leaves, right? So what is the first digit that we have? 5, 3, 7, 8, 9, 3, 5. So how can I write it? What are the numbers that I have? I have 3. And then I don't have 4, right? No 4 is here. And then I have 5. What else is there? 6 is not there. 7 is there. 8 is there, and 9 is there, right? So what are the leaves corresponding to it? So in front of 3, what do we have? 66. In front of 5, we have 28 and 23. So what you will do is 23 and 28, right? What else is there? In front of 7, we have 0, 0. And then in front of 8, we have 34. And then 9, we have 53, right? Yes or no?
Yes, ma'am.
So, यहाँ पे you just mention what is the stem and what is leaf. So, what was your stem? Which digit you had? The 100th place digit.
Yes.
And then what were your leaves? 10th and unit place, right? So you can write it like this. All right. This is fine.
Yes, ma'am.
Okay. All right. Let me pick one more example which is related to decimal. So let me just grab some examples. Let me just do that. So you can take up one example. Which is something like, okay, we need a decimal, right? Let's do that. Okay, we have lots of decimals here. Okay, I'll just grab this example. Or how do you deal with this also? Let's do that. Okay. All right. Okay, so we have the data available now. Let's see. So let's say you have something like this. So this is a question from your book only. Let's try to solve this. So what is this question saying? That the accompanying specific gravity values for various wood types used in construction appeared in an article. And these are the numbers that we received. And then you have to construct stem and leaf diagrams, stem and leaf display using repeated stems and comment on any interesting features of the display. Okay. All right. So here, what do we see? We have all the numbers. One specific feature of all these numbers is every number is starting after the decimal, right? So 0.31, 0.35, 0.36, 36, all these numbers are there, right? So there's no number which has 1.31. So all the numbers will be after the decimal. So just you have to treat it like a normal number, and your leading digits, it could be this, no? So this. These could be your leading numbers, right? So what you can do is you can write it like this. So first of all, what is your stem? And then what is your leaf? So how do you write it? So what are your stem?
Oh, ma'am, 3.
So 3, 4, and then 5 also, and then 6 also, and then 7 also, right?
Yes.
3, 4, 5, 6, 7. That's all, right? And what are your leaves? So your leaf is, so all these numbers are written in ascending order only. So it's very convenient for us. So we'll just write 1, 3, 1, 5, 6, 6, and 7, right? And 8 also. So 1, 5, 6, 6, 7, and 8. And then 4, 0, 0, 0, 1, 1, 2, 2, 2, and 2. And then, oh my God, this is going to take a lot of space. So let's just reduce this size. So we have 2 5 times 1 2 3 4 5, and then we have 3, and then we have 4 5 6 6 7 8 8 8, right? These are the numbers that we have. So how do we know if it's 31 or 0.31? It's given, na? It's 0.31, Narmada. And when we write, what is my stem and what is my leaf, then I will write the first digit after decimal. Right?
Okay, ma'am.
All you have to do is you just have to clarify what was your stem, right? So one idea could have been to write it like 0.3, 0.4, 0.5, 0.6, 0.7. The other could be you just specify what is your stem here, and then people can understand, okay, stem was this. Okay, like that. So first place after decimal. And then as leaf, you can also write your second place after decimal. So whenever you draw graphs, you have to write, what is on the x-axis, what is on the y-axis, whatever units they have. Similar logic here also applies. So you can mention what is stem here, what is leaf here, and then you are done. And then for the 5, what do we have here? You can write, it's 1, and then it's 4, 4, 5, 8, and then for 6, it is 2, 6, 6, 7, and 8, and then it is 5, right? So the question also asked, do you see any interesting feature? So do you see any interesting feature here? Can you say something about anything special about this? What can we say? So you see, majority of the data is lying here only in this line.
Yes, ma'am.
You have most data points here. So if you would have made a histogram of this, it would have looked like this, right? So what kind of a data is this? How many peaks do you have? 1 peak, right?
Yes.
So this is unimodal data, right? Very nice. Or you can say most of your values are concentrated around 0.4, right? So these are the features that you can say. So there is a single peak, that is something that you can say. And is this data symmetric? Whatever is on the left side, is it mirroring what is on the right side?
No, ma'am.
So it's not symmetric, right? So these are some things that you can mention regarding your diagram. Is that all right?
Ma'am, in case of, for example, 5.35, we will take it as 535 and then segregate into stem and leaf.
So most of the time, whenever you will see data ना, जो आपको stem and leaf में बनाना होगा, वो एक similar pattern का होगा.
Yes, ma'am.
So मतलब जिसमें similar digits होंगे, not too many differences in digits. So whenever there are a lot of difference, then this method doesn't work very properly. Then you go to different methods, histogram or other methods. So whenever the data is very, similar digits are there, then only you try to plot it. Otherwise, we don't use it. And you can see this also, that this is not so good also. When you have a lot of data, it's very problematic, right? So you
Yes.
don't follow it that much. Okay. Ma'am, what about skewness? Okay. So where is it skewed? Which tail is longer? So, if your diagram is like this, what kind of a skewness it is? This is positively skewed. And we see that, like 3 was here. In our case, in this particular example, 3 was here, and then 4 was very peaked, and then similar like this, right? So this is positively skewed, right? If you plot it like this, it has a very long tail on this side. Not very long, but long, right? So it's positively skewed. Yes. If these numbers, more numbers would have been on this side, then it would have been negatively skewed. Okay. So this is positively skewed. All right. So there is another method which is similar to this, which is called dot plot. So the other method to draw is something which is called dot plot. So what is a dot plot? It is also a method to pictorially draw your data when the data size, the number of data points that you have is small. Only in that case it works very well. Small, or when you have relatively few distinct values. So what you do in making a dot plot, every single observation is treated like a dot. Every single observation will be a dot for you. And if more and more, same numbers are repeated, you keep putting a dot above that dot. And if they are distinct, you keep putting it differently in the number line. Okay. So, and what kind of information it will tell you, what is the location of the data, how much is it spread. Spread meaning how far is the data. Okay. And then what are the extreme points? And then how much gap is there between data. So all these things you get to know using this. So is skewness applicable to unimodel only and not bimodal or multimodal? We usually do not talk about skewness whenever we have bimodal or multimodal data. Yes, we do not talk about that. Okay. Because when you have, so let's say when you have, so in this case, when you have a data like this, what will you call it?
Bimodal.
You will call it bimodal, but what will you call, like, how will you say the skewness?
Okay, ma'am.
So majorly, whenever we talk about skewness, we typically have a unimodal data in our head. We can still talk about it. I mean, the main logic is if you have lots of observation, if your tail is very stretched out on one side, on the positive side, then you call it positively skewed. But it doesn't make too much sense whenever we have a bimodal data. So typically, whenever you will hear conversation regarding skewness, you will have a bimodal data, unimodal data. Okay.
Okay.
But there is no hard and fast rule. You can say these things here also. Okay. All right. So how do you make a dot plot? So let's say we have the following observations. So let's say we have age of different students here. So their age is the following. So 11, 5, 9, 13, 8, 9, 9, 11, 10, 8, 6, 7, 12, 11, 13. So let's say this is the data that we have. Okay, this is the data that we have, and we have to plot it in a dot plot. So what do? You just make a number line first. So this is your number line. And then you plot all the numbers which are relevant for you. So basically, we can see that my numbers are ranging from 6 till 13, right? So let's say you have 5 here, 6 here, 7 here, 8 here, 9 here, 10 here, 11, 12, 13, 14. This is how you make a number line. Now what you have to do is, whatever observation that you get, you just put a dot above this. Okay. So what you can do is, you can have something like this. So let's say starting from 6, we see a 6 here. So I'll put a dot here. Do we have any other 6? 6 is done. Do we see any other 6? No. Do we see a 7? So I'll put a dot here, 7. Okay, I have a 5 also here. Okay, so I'll put 5 here. 5 we've put. What else? Do we have a 8? We have 2 8s, right? So what you do is you put 1 dot here and then again 1 dot here. Okay. All right. Now we have 9. So we have 1, 2, and 3. There are 3 9s, right? So you put 1 dot here, another dot on top of it, and then another dot on top of it. Okay. 3 dots. Then we have a 10. We only have a single 10. So we'll put it here. And then we have 11. How many times? 1, 2, 3. So 3 times 11, 1, 2, and then 3. Okay, what else now? 12, how many times? Only single, 1 time. So 12. And then 13, you have 2 times, 13. So we put 1 here and then 1 here. So this is your dot plot. So whenever your data size is very small, you can make this dot plot. But you can imagine if you have a very big data set, it's not possible, right? You cannot keep making this number line so big and keep repeating this, right? This is a very manual process, right? So it's not very feasible for us to draw whenever we have a very large data set. So this tells us what kind of a data does this look like? Unimodal, bimodal?
Bimodal.
Right? There are 2 peaks. And it's spread out. Its lowest value is 5, its biggest value is 13, right? The extreme values we got to know. Its spread also we got to know. How far is it spread, right? Which values are getting repeated multiple times. So 9 is repeating, getting 3 times, 11 also. So all these things you get to know using dot plot. So whenever something like this is asked, you just have to follow the same process. But it's not very useful for a very large data. Only when you have a small data, you make it like this. Is that all right?
Yes, ma'am.
ठीक है, सो ये डॉट प्लॉट हो गया है और ऐसे ही स्टेम एंड लीफ है. अब ये सारी चीजें देख के आपको वैसे ही पता चल रहा है दिस इज सच अ वेरी मतलब बहुत मैनुअल एफर्ट है, लॉट ऑफ मैनुअल एफर्ट इज देयर. So majorly we do not use it that much. We use histograms and then we use other sorts of diagrams to represent data. Okay. So, but for the sake of completeness, we should know what this is and how to draw this. Okay. All right. Moving on. Let's continue our discussion. And now let's start talking about how do you present data in form of numbers, right? So when you have a lot of data, there are some important numbers which will give you what is the central position of your data. So what are different measures of location? We want to know that. Okay. So what are the different measures of location? So measure of location meaning all those, formulas, all those numbers which tell you, which describe the location of a data set. Okay, so what are those formulas that, okay, what is spread and extremes? So spread meaning, spread as the term meaning, the term means spread meaning how far is your data? How is it spread? Is it like this? So, you saw a dot plot here. So is it like this? Is your data like this? Very concentrated? Or is it your data like this? So this data is very spread out. This is very concentrated. So this is spread. Spread in terms, basic term mean how far away is your data? Is it very concentrated? Is it very sparsely located? Extremes meaning like what is the minimum value? What is the maximum value? What are the points at the extreme left? What are the points on the extreme right? That is what extreme means. Okay.
Okay, ma'am.
Simple English terms. Okay. All right. So what all measures do you know which tell you the location of your data? What are the different things that you have read so far? क्या क्या पढ़ा है आपने?
Ma'am,
Mean,
mean,
median.
median, mode.
Mean, median, mode. अभी आप जो है एक नया you will also get to know about one more thing which is called trimmed mean. Trimmed mean we will also get to know. So what is mean, what is median, what is mode, what is quartile? All these things we will get to know. Okay, so let's start talking about it one by one. All right. So first of all, mean. What is mean? So if you have to calculate sample mean, so let's say if somebody gives you a sample, so you have a sample of data and you have to calculate the mean. So sample mean, which is represented by, x bar. X bar. Whenever you see this term, this means you're calculating sample mean. Okay. Sample mean of observations x1, x2 up to xn. If these are the values that you have in your data, so what is a sample mean? It is given by, so what is x bar? You sum all these values, x1 plus x2 up to xn. You add all these numbers and then you divide by n. What is the number of values? How many observations do you have, right? So that is your sample mean. How else can we represent it? When you have added all these numbers, there is one compact way of writing it. What is that? So whenever you add different numbers, you can write summation. This big symbol means summation, meaning you are adding the numbers. Okay. What are the numbers that you are adding? You are adding x1, x2, x3, x4 up to xn. So what is the general number that you have? xi. Here, this I value is taking different numbers. I is going from 1 to n, right? So you write that this I is taking minimum value 1 and this taking value maximum n. So you write it like this and then you divide it by n. This is your sample mean. Is that fine?
Yes.
ठीक है, तो ये symbol है हमारे sample mean का. This is the symbol. Okay. So this is your x bar. Fine. So this was basically sample mean. Okay. How do you find population mean? We understand the difference between population and sample. Population is whatever phenomena या process you are discussing. If you have all those values with you, that is a population data. And if you have only a subset of that population, that is called sample. Okay. So population mean. How do you calculate population mean? Population mean is usually represented by a term which is called mu. This is called mu. So whenever you see this term mu, you think about population mean, that you have a population and mean value of those population numbers is given. So population mean is basically the average value, average of all the values in the population. That is population mean. Is that okay? So whenever you are given all the data regarding a population, if you find the average of it, that will be population mean. And it has a separate symbol for it, mu. Okay. All right.
Yes, ma'am.
Okay, fine. Okay. Okay. All right. So what could be the possible? So guys, when we were discussing that what is the objective of statistics, then we said we don't know the entire population and we want to say a few things about population. We can't collect all of that data. So what do? We pick a sample from the population and we calculate some number and try to say, okay, this number kind of represents my population. Okay. All right. So what if, so your goal always is to estimate population different parameters regarding your population using sample data. Okay. So what you always try to do is find sample quantities to figure out what are your population parameters. So like what is population mean? What is population variance? What is population standard deviation? We always want to know these things, but we do not have the population data, so we cannot calculate that directly. So what we try to do is we pick a sample and then we try to find the sample mean, sample median, all of these things and try to say that, okay, this is the number which is closest to sample mean, population mean. That is my best guess. So whenever you try to guess something about population, you call it a point estimate. Okay. So let's say, for example, we can say that sample mean is my best guess for what my population mean could be. So let's say if my goal is to calculate the average marks of BA economics students in Delhi University, I can't calculate, I can't ask each student and find that data. So what I do is I pick 2 students from each college and take the mean of their marks. So that is my sample average. And then what I try to say that, okay, whatever sample average I've gotten, that is my best guess for what is the average marks of BA economics students in Delhi University. So what I've tried to do is I have tried to guess what is the population mean. Okay. So we basically try to calculate point estimates. So what is a point estimate? It is a single number. It's a single number that is our best guess. For the population parameters. Okay. So let's say if we want to calculate population mean, so our best guess would be using sample mean, right? Okay. What could be the problems with sample mean? Why could sample mean have a lot of problem? Or could sample mean can it have a problem?
Yes, ma'am. For example, say if we pick the samples from the population, it might not cover whole characteristics of the population.
Very nice. It could be very well happening that, there are very extreme values which can influence the mean value a lot, right? So there could be outliers, right? So mean value is very much affected by outliers. Mean value is greatly affected by the presence of outliers. Right? So like, if you have to calculate the average of 5, 10, 15, and 20, and then 25. So what is that going to be? So we have 15 and then 15, 30, and then 30 and 20 is 50 and then 75, right? So 75 divided by 5. What is that? 25. So my sample mean is 25. But instead of this 25 value, I just replace it by 100, let's say, right? 5, 10, 15, 20, and 100. Now what is my sample mean? This is what? 150 divided by 5, which is how much is this?
For 30.
30. And guys, this is not 25, this is 15, right? So what has happened? When I had one extreme value, it kind of shifted my sample mean by a very large amount. So this tries to tell us that whenever there are outliers meaning very extreme values, extremely high or extremely low, right? So extremely low values, extremely high values, whatever those values are, they are called outliers. So the data which is not typically seen, okay, very high values, very low values, they are called outliers, okay. So whenever there are outliers, my mean value is very much affected by it, right? So are there any measures which are very resistant to outliers? So is there any parameter or is there any method of calculating, the measure of location which is not affected by outliers?
Median.
So that is median, okay. So we try to figure out what is median. So basically we are trying to understand what is the reason, what is the logic for, having something like median. Why can't all our purposes be done with mean only? Because it is not very resistant to outliers, okay. So what is a median? So first, what do you have to do? If you have to calculate the sample median, what do you do? Sample median is obtained. First, you have to do what? First, you have to order your data by first ordering the n observation. So let's say you have a data which has n data points. So you have to first order the n observations from smallest to largest, right? So from smallest to largest, you order your data, right? So smallest value and then bigger and then bigger and then the largest value. And after that, then what do you do? So then you have to do the following. First, sample median is represented by this term. Okay, this is the symbol for sample median. So the sample median, so if my number of observations is odd, if n is odd, then what is my sample median? It is the n plus 1 by 2th observation in that ordering. So median is not this number. Median is whatever this number will come. So that will be the position. Okay, if this comes out to be 10, that means in that ordering, whatever my 10th position is, whatever that number is, that is my median value. Okay, so this is your median value if your n is odd. And if your n is even, then what happens? If n is even, then what is the median value? That is basically the average of n by 2th and n by 2 plus 1 1th ordered value. Okay. So basically what that means is, let's say if you have these data points, 8, 3, 9, 7, 6, 4. Okay. So what is your first step? You have to write all of this data in ascending order. So first you have 3, then you have 4, then you have 6, then you have 7, then you have 8, and then you have 9. So you have ordered the data. Now, how many data points you have? You have 6 data points. So here n is even. So what will be your median? So what you do is, since this is even, you have to take the average of n by 2. What is n by 2? 6 by 2 is third. So you have to take the average of third and n by 2, which is 3 plus 1, which is fourth. So third and fourth ordered value, you have to take the average of that. Okay, so what is the third value? This is first, second, third. So this is third value. Sixth is the third value. And 7 is the fourth value. So you have to take an average of these two numbers. So what is the average here? What is the average of 6 and 7?
6.5.
So you have to do 6 plus 7 divided by 2, which is 6.5. So that is your median, right? And if let's say we would have had this, so instead of 9, we also had a 10. So now you have 6, instead of 6, you have 7 data points. So what is your median value? N plus 1 by 2. So n is 7. 7 plus 1 is 8. 8 divided by 2 is 4. So whatever is your fourth value, that would have been your median. So what is your fourth value? 1, 2, 3, 4. So 7 would have been the median value in that case. Is that all right?
Yes, ma'am.
Okay, we can calculate all of that now. So you have to first put everything in ascending order, then find if n is odd or even, and then do the calculations accordingly. Okay. All right. So, okay. And this particular measure, this is very insensitive to outliers. So like instead of 9, if I would have had 100 here, my median would still have been the same, right? चाहे मैं यहाँ पे 100 लिख लूँ या 1000 लिख लूँ, median would have been 6.5 only. या फिर, or I could have done, minus 100 here also. This could have been very, very small. Irrespective of whatever the number is here, my median would still have been 6.5 only. So what we can say is this measure median is very insensitive to outliers. Matlab, it is not sensitive at all. It doesn't changes with outliers. Okay. So it is very insensitive. So sample median is very insensitive to outliers. Okay. So that is the situation. All right. Now, okay. So let's say, okay, so like I gave you this number, no? Population mean is represented by mu. If we have all the population data, if we put all the population data in ascending order, and if we try to figure out the median in the similar manner, we will get population median. And there is a very specific symbol for population median. And what is that? So population median is represented by this term. Okay. So whenever you see this, that means they are talking about population median. So median value of your entire population data. Is that okay? All right.
Yes, ma'am.
Okay, ji. Chalo. Now I will show you a few diagrams and I have few questions from you. Okay. Let's try to answer that. Okay. So let's say I have some data and let's say it looks like this. Okay, and let's say I have a data which looks like this. And let's say I have a data which looks like this. Okay, so first of all, can you tell me which is symmetric, which is positively skewed, which is negatively skewed?
Ma'am, first is symmetric. The second one is negative skewed. And the third one is positive or skewed.
Perfect. So this is negatively skewed. This is symmetric and this one is positively skewed. Okay, all right. So my question to you is, you have to tell me what is the median value, what is the relationship between mean and median value for each of these diagrams. So let's say all the population data is given to us. So this is your population mean and this is your population median. So you have to tell me, are they same, which is greater, which is less in each of the diagram. Okay, that is your task. So tell me, what do you think? So whenever my data is symmetric, what happens? So let's say if this would have been this.
Ma'am, in case of symmetric, the median and mean would be same.
Okay. And why do you say that?
Ma'am, because the values on the right side of the y-axis and left side of the y-axis are distributed equally.
Very nice. So basically what is happening here? So because this data is symmetric, that means whatever is on the left side, exactly same pattern is being followed on the right side, right? So if you try to find the median, what is median? The central value, right? The midpoint, right? So midpoint will be here only, right? And whenever you try to find mean, what do? You keep calculating and adding and everything, right? So this value plus this value, the addition will be here. This value, addition will be here. Everything will be centered around this point, right? So whenever you have a symmetric data, so one of the distinctive features is the mean value is exactly equal to the median value, right?
Ma'am, can you explain once again?
Yeah, so let's take an example, okay? So if my data is symmetric, so let's just take this example, okay? So let's say I have values 1, 2, 3, 4, 5, okay? 1 comes 1 time, 2 comes 2 times, 3 comes 3 times, 4 comes again 2 times, and 5 comes 1 time. What kind of a data is this? Symmetric, right?
Yes.
Okay. So here I'm not doing that. I'm just saying, okay, this is 1, this is 2, this is 3. These are the numbers. Okay. So if you have to find the mean of this, what do you get? What is the mean value? 1 is coming 1 time, so 1. Plus 2 is coming 2 times. So what is the sum there? 4.
4.
Plus 3 is coming 3 times. So what is the sum there? 9. 4 is coming again 2 times, so 8. And then 5 is coming 1 time, so 5, right? Yes. And then you divide it by what? 1, 1, 2, 2, 2, 4. 4 plus 2, 6. 6 and 3, 9, right? Number of observation is 9. Yes or no?
Yes, ma'am.
Okay. So if you do this, if you add this, what do you get? 5 and 1, 6. 8 and 4, 12. Okay. So 12 and 6 is 18. 18 and 9 is what? 27. And 27 divided by 9 is what?
3.
3. So what is my mean value? 3. Okay. And what is my median value? Median value is what is the central number. Okay. So what is your data? 1 is coming 1 time. 2 is coming 2 times. 3 is coming 3 times. 4 is coming 2 times. 5 is coming 1 time. Right? How many observations you have? 9. So which observation is the median? The fifth observation is the median, right? Yes or no? Because what we will do is n plus 1 divided by 2, whatever that observation is, right? So which observation is that? The fifth position? 1, 2, 3, 4, 5. This is my fifth position. And this is 3, right? So what is my median value also? 3. Yes or no?
Yes, ma'am.
So 3 is my median value. So what do we see here? That my median value and my mean value, are they the same? Right?
Yes, ma'am.
This is okay.
Yes, ma'am.
So this is what is happening. So here we've made a diagram and we are seeing it like this, like we've made a histogram. But typically, whenever you do this, that means, this and this, their center is this and this, their center is this. Everything will be centered at this point. So if a data is symmetric, their mean and median value is exactly the same. Okay. Now, following the same logic, if let's say we have a negatively skewed data, then what happens? What do you think? What do you think?
Ma'am, how can we say it in theoretical terms? Like, how do we write it? The first one.
Okay, so first one, theoretically, you can say because the data, whatever the data is there, both on the left side and right side, it's exactly symmetric. Okay, just give me one moment. Tell me this. What is an average value? So let's say if there are 5 people, 5 people, 5, 10, 15, 20, and 25. What is the mean value of this?
15.
15 only, right? But can you see that, okay, if you calculated the average of 5 and 25, what is that?
15.
15 only. So instead of writing 5 and 25, we could have written 15 only 2 times, right? The sum would have still been 30, right?
Yes, ma'am.
And instead of 10 and 20, what is the average of 10 and 20? 15 only.
Yes, ma'am.
So instead of 10 and 20, I could have just replaced it by saying that, okay, it is 15 and 15 only, right? So basically, if I have 5 numbers which are 15, my average is 15 only, right?
Yes, ma'am.
Yes, ma'am.
So it's like I am distributing I'm distributing my numbers. So, okay, my screen has stopped moving. Yeah. So it's like I'm distributing my numbers. So if you have data which exactly looks like this at this distance and this distance, so when you take average of this and this, it will be this center, right? When you take the average of this and this, it will be at this center. So it is like you can replace all the data with whatever number this is, and that will give you this same average. So you can say because, all the data points is symmetric around mu, the mean value is mu, right? All the data is centered around, let's say this number is 10, that all the data is symmetric around 10, the mean value will be 10. And because the data is such that, it grows till here and then it falls down here, the central value is this only. And whatever is your central value is your median value, right?
Yes, ma'am. Ma'am, will it be asked in the exam why is it equal? Anything like that?
Not in this manner, not necessarily in this manner, but you should just know all of this. And then you can use examples to explain all of this.
Okay, ma'am.
Okay, all right. Chalo, now you tell me what is the relationship going to be here in this case and in this case. Okay, so for the second place, negatively skewed, where is the mean and where is the median? So is mean greater than median or is mean less than median? That is the question.
Ma'am, I think in negatively skewed, the mean would be on the rightward side as
Okay.
compared to the median.
Okay, so mean towards the right, you are saying.
Yes, ma'am.
So mean towards the right and median to the left of it, right? So first, what will come? Median?
Oh, yes, ma'am.
Okay, first median will come. Okay. All right. Chalo, let's take an example again. So instead of this, let's say this, we have this. One, two, three, four, five. Okay. And I have to make it negatively skewed, no? So this is, let's say, one. This is two. And this is again two. And then this is again, let's say this. And then this is this. Same. This looks like a negatively skewed data or not? This tail is longer, right?
Yes, ma'am.
Okay, so this is one time, this is two times, this is two times, this is three times, and then this is two times. So what is the mean and what is the median here? So let's calculate. What is the mean? Mean will be 1 times 1 plus 2 times 2 plus 3 times 2 plus 4 times 3 plus 5 times 2, 10. And how many numbers are there? 6, 7, 8, 9, right? What is the value here? 5 and 6, 11 and 23 and then 10, 33. 33 divided by 9, right? What is this? 11 by 3, which is 3 20, meaning 6. 3.66, right? That is the mean.
Yes, ma'am.
And what is the median? Which number, which observation will be the median? Fifth observation. Because there are 9 observations, 9 plus 1 divided by 2. Fifth observation will be my median. So what is the fifth observation here?
Oh, ma'am, 3.
Okay, the fifth observation that we have here is 3, right? Okay. Yeah, fifth observation is 3. So what do we have here? Which is lower, which is higher?
Oh, ma'am, mean is greater than the median
Mean
in
is,
case of.
yeah, mean is greater than the median. 5 to 10, 3, 4, 12, 3 to 6, 4 and 1. And then this is 22, 32 and 33, right? So my mean is greater than median, right? If I would have reversed this situation, then what would have happened? So now try to think about what is going to be the case here? So in this case हमें क्या देखने को मिल रहा है कि अगर हमारा सिस्टम इस तरीके का है, तो हमारी जो मीन वैल्यू है वो बड़ी आ रही है relative to my median value, right?
Yes, ma'am.
So my mean value is coming here and my median value is coming here, somewhere here, right? So what should be the case with the positively skewed data? The reverse of it, right? इसका उल्टा हो जाएगा.
Yes, ma'am.
So यहाँ पे क्या होने वाला है? This is mu and let's say this is mu and let's say this is mu tilde, right? Is that all right?
Yes, ma'am.
So these are certain comparisons that we can do regarding mean and median. So these are some of the features which we also use to find if our data is negatively skewed or positively skewed just by looking at these two numbers. Okay. Is that fine, guys?
Oh, yes, ma'am.
Okay, let's do one thing now. Let's take a 10 minutes break and we'll resume after that. Okay. It's 7:09. Let's resume at 7:19. All right, so I think we kind of made a mistake here. First of all, the number of observations that we have here, it's not 9. You see this? 1, 2, 2, this is 5, and then 3 and 2, it's 5. 5 plus 5 is 10, right? Not 9. So that one thing we've done incorrectly. So it's 10. So what is this mean value going to be? And just checking if we've done this also correctly. 1, 4, 6, 12, and 10. If you add this, you get 33. So what is your mean going to be? 3.3, right? Is that okay? So वो एक हमने mistake कर दी थी. ठीक है जी? Is that all right?
Yes, ma'am.
And apart from that, now if you have 10 observations, what is your median? It is the average of which value and which value? 10 by 2, which is 5th, and 6th value, right? So what is my 5th and 6th observation? My 5th observation is 3 and my 6th observation is 4, right? So 5th observation is 3, 6th observation is 4, and the mean of that is 3.5, right? So what is the relationship that we have here? That my median is greater than my mean, right? Is that okay? Right? So we have to do this differently. So yahan pe what we had was my median was greater than the mean value. So the reverse is going to be there in the positively skewed part. So we have here median value less than mean value. Okay. So in case you have written down anywhere, just make these corrections. Okay. So yahan pe what happens? Median is greater than the mean value, and here mean value is greater than the median value. Is that okay?
Yes, ma'am.
So just make these corrections in case you've written anywhere. Okay, so we have mean, median. All right, now there is something called quartiles. Okay, so like median, what does median do to our data? क्या करता है median data के लिए? It divides it into two equal parts, right? Two halves it divides. Now, instead of two halves, let's say if you want to divide your entire data into 4 equal parts, then that is quartiles. So what is quartile? If you divide the data into 4 equal parts. You get quartiles. So how many quartiles will you have? To divide the data into 2 equal parts, how many numbers do you need? How many numbers do you need to divide the data into 2 equal parts, which is the median?
Ma'am, at least 2 numbers.
No. So, अगर आप अपने data को, if you have to divide your entire data into 2 parts, which number does the job? Median? Median is only a single number, right?
Yes.
So, if you have to divide your data into 4 equal parts, how many numbers do you need?
Ma'am, 3.
Exactly. Very nice. So, you need 3 points, right? So, let's say your data is like this. So one would be median, and then one would be half of this, and then one would be half of this. So you basically would need 3 points, right? So it'll be called first quartile. And then this is median. And then this is the third quartile. Okay. So what does a quartile do? It divides your data into 4 equal parts. So this is first part. This will be your second part. This will be your third part. And this will be your fourth part. Is that fine?
Yes, ma'am.
So this is called quartiles. There is something called percentiles also. Have you heard of the term percentile?
Yes, ma'am.
So what is a percentile?
Oh, center. Ma'am, I think it divides into 10 parts.
No. Have you heard of the term that I got 99 percentile in CUET exam? What does that mean?
Oh,
So
ma'am, 100.
yes. What does that mean? आपके जो score आया था, the CUET score that you guys had, it has had some percentile, right? Or no?
Yes, ma'am.
So it had,
Thousand.
right? उसमें percentile term use होती है. So percentile actually क्या होता है? Percentile tells you how many students have scored lesser than you. So if somebody says that I have received 99 percentile score, what does that mean? That I am above 99% of the students who gave this exam, right? That is
Yes.
what it means. So percentiles का meaning क्या होता है? It basically means, so let's say if somebody says nth percentile, what does that mean? It will separate the lower n% from the upper 100 minus n% of data. So nth percentile. So percentile can be calculated for any n value, right? Going from 0 to 100. So let's say if I say 50th percentile. So what does that mean? It will separate my data from the lower 50th and then upper 50th, right? So nth percentile means what? 50th percentile means what? That it is that number which will separate the lower 50% with the upper 50% of the data, right? 99 percentile. What does that mean? That it will separate 99% lower data and then here 1%. So it is that number below which we have 99% data points and above which we have only 1% data points. Is that all right?
Oh, yes, ma'am.
So what is a 50th percentile? What is that point which divides the data into 50% and 50%? What is that? Have we read something related to this? What does median value do? Median value क्या करती है?
मैम उसके जो बीच की वैल्यू होती है उसे डिवाइड कर देती है.
So basically median value is doing what? 50% of the data on one side and 50% of the data on the other side, right?
Yes, ma'am.
So what is my 50th percentile? My median?
Yes, ma'am.
Your median is your 50th percentile, right? So in your exam, if you get a score of, let's say I got 97 percentile. So that doesn't mean you scored 97%. So that doesn't mean you scored 97 marks out of 100. That means out of all the people who gave the exam, 97% people had marks which were lower than you, and only 3% people had a score which was higher than you, right? This is the meaning of percentile, okay? Later on in our course only, we will understand how to calculate these, okay? So don't worry about that. 97% of the data is to the left of this point. And 3% of the data is to the right of this point. Okay. Is that all right? Is the meaning clear?
Yes, ma'am.
You know, when I was in college, I did not understand the meaning of percentile. So, you know, there was somebody who came, so there was some session which was organized. So that person has scored 100 percentile in MBA exam. So I was like, he scored 100 out of 100 in everything. And I was very shocked. And then later on, when I got to know that percentile means that he was a top scorer, right? So he could have scored 70% marks in his exam, but he could be 100 percentile, right? So is that possible?
Yes, ma'am. It is.
It is, right? Because percentile would just mean that you are the top scorer. You had scored the most marks. It doesn't matter how many marks you've scored. It just tells you which position you are at. Okay. So that is something which was an eye opener for me. Okay. All right. So, guys, so far so good. This is fine. कोई problem तो नहीं है?
No, ma'am.
Narmada, this is okay with you?
Yes, ma'am. So
Okay, perfect. All right. Chalo. Now let's continue our discussion. And you see, we have seen mean. We have seen median. Whenever we talk about mean, we take care of all the values, right? We think about all the values that were there. So we take into consideration every single value which is a part of our data, right? So we can say that we are not leaving any amount of data, right? While calculating mean, we are considering every single value. So can I say that it involves 0% trimming of data? Trimming of data mean removing data. Trim kar dena, trim. So just chop, cut kar do. So mean may there is no removing of data, right? Because you use every single point. In median, what happens? Whenever you calculate median, you don't care what is on the left, you don't care what is on the right. All that matters to you is those, if the data is even, those two middle points, and if it is odd, that one central middle point. You don't care what is happening to the left, you don't care what is happening to the right, as long as the position is the same, right? So whenever we talk about median, there is maximum possible trimming of data that can be there, right? maximum possible trimming of data. So what is happening? No trimming here, 0% trimming here, maximum possible trimming here. So we have another concept which is called trimmed mean, which is called trimmed mean. Which is some sort of a middle ground between these two, because mean is very sensitive to outliers. Median is very insensitive to outliers. So now we are looking for a middle ground, right? Which kind of is in the middle of these two. So that concept that takes, so the trimmed mean that we have here, it takes care of this. So it's a middle ground between mean and median. So you are trimming something, but not everything like we do in the median. So what is a trimmed mean? Trimmed mean, we'll understand how to calculate it. So what is trimmed mean? It's kind of a compromise between these two. And what do we do in this? We trim some observation, trimming observations, right? So what happens in trimmed means? So if somebody tells you that you have to do 25% trimming, people will tell us, okay, you have to do 10% trimming, you have to do 20% trimming, you have to do 5% trimming. People will have to give us numbers. What level of trimming do you want in the mean? So if they say 5%, we will remove 5% of the data. If they say 10%, we will remove 10% of the data. So trimmed mean meaning when you trim your data points and then you calculate mean. Okay. So how do you calculate trimmed mean? What are the different methods? We will try to understand that now. Okay. So what is trimmed mean? That is our goal here. Is the objective clear why we are talking about trimmed mean? Because we want some middle ground between mean and median. Okay. So usually, if somebody gives you a trimming of 5% to 25%, that is a good enough measure of the center of the data. Okay. So
Ma'am, what does middle ground mean?
middle ground matlab कि मान लो you are having a argument with your friend. Okay. He's saying that we will go to so have you traveled by metro by now anywhere?
Yes, ma'am.
You
To the
have?
Vishwa.
Okay.
Yes.
So you've explored the yellow line, right?
Yes, ma'am.
Narmada, what about you?
No, ma'am, I haven't traveled by metro.
Okay, you haven't traveled by metro. Chalo, okay, let's take another example now. Uh, okay, so, let's say you are saying that I want to buy something which is worth rupees 10,000. You're telling your parents, I want to buy something which is worth 10,000. Your parents are saying that, okay, you take something which is worth 2,000 rupees. Okay. So what is the middle ground? You say, okay, ना आपकी ना मेरी कुछ 5,000 की चीज खरीद लेते हैं. Like you do it a lot with the shopkeepers, na? They quote a higher price, you quote a very low price, and then you're in the middle. So that is a middle ground. So like a compromise between these two. Okay, that is the term, that is the meaning of the term middle ground. Okay, so that is the logic. So like here we are saying trimmed mean is kind of a middle ground between these two. So it is not insensitive to outliers and it is not very sensitive to the outliers also. So it's kind of a middle ground. So here every observation was being used. Here only the central two observations were used. So these are two extremes, using everything using only the central points. So trimmed mean will be a middle point of this, like middle ground you are taking. Okay. So how do you find trimmed means? That is the objective now. Okay. So if somebody says that you have to find if the trimmed mean percent is 100 alpha percent. That means, let's say if somebody says, okay, I will rather use an example first. Okay. Let's say if somebody says you have to do 10% trimming, you have to find 10% trimmed mean. Okay. If somebody says whatever your data is, find 10% trimmed mean. Okay. So what does that mean? And let's say you have n observations. And this n here is, let's say, 26. Okay. So you have 26 data points in your data, and somebody asks you, please find 10% trimmed mean. Okay. So, okay, I don't want to use this example right now. Let's say somebody says n observation and n is, let's say, 20. Okay. So what is 10% of 20?
Or 2, ma'am.
2. So what do you have to do is, whenever you put your data in ascending order, you have to remove the leftmost 2 points and you have to remove the rightmost 2 points, right? And then whatever data points are left, you have to find the mean of that. Okay. So 2 points here and 2 points here. The leftmost 2 points, rightmost 2 points you have to remove, and then whatever points are left. So there are 16 observations left now, right? So what you have to do is you have to find the mean of those 16 values. This is how you find 10% trimmed mean. So 10% trimmed mean would mean what? You have to remove 10% of observation on the left, 10% observation on the right, and then you have to calculate the mean of whatever data is left. Is that clear?
Yes, ma'am.
So like, if somebody says this, that okay, 1, so let's say my data points are like this: 8, 12, 15, 17, and then 20. 1, 2, 3, 4, 5, and then 6. And then 24, 27, 28, 29, and 30. Okay. So let's say these are my data points. How many observations do I have? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 observations. 10 observations. So if somebody says that please find 10% trimmed mean, so what do? First find what is 10% of 10, the number of observation. So what is 10% of 10?
1.
1. So what you do is 1 observations from the left and 1 observation from the right when your data is put in ascending order. Whenever your data is put in ascending order, remove 1 observation from the left, 1 observation from the right, and whatever is left in between, just add all these numbers and then divide by 8. Whatever that number will come, that will be your 10% trimmed mean. Is that okay?
Yes, ma'am.
What is, yeah. What is 20% trimmed mean of this? If somebody says 20%, then what do? What is 20%? How will you find this? What will be 20% trimmed mean?
Oh, ma'am, 2.
So
2
20.
from the left and 2 from the right.
Very nice. So 20% of 10 is what? 2. So you remove 2 observations from here and 2 observations from here. So whatever is left in between, you add all these and then you divide by 6. That is your 20% trimmed mean, right? Is that okay?
Yes, ma'am.
All right. Okay. So now, sometimes let's say somebody said that, okay, you have to find 15% trimmed mean. Then what do? What is 15% of 10? What is 15% of
Ma'am, 1.5.
1.5, right? Now what do I do? Can I remove 1.5 observations? No,
No, ma'am.
right? So this is not possible, first of all. So आप ऐसा तो नहीं कर सकते कि 1.5 observation यहाँ से 1.5. This is not possible. So what you have to do? So, whenever this number that you have, this is not an integer. If this is not an integer, if this is not an integer, then what happens? Then you see, what is 1.5? It is between 1 and 2, right?
Yes.
So what you do is, first, you remove one observation from both sides and then calculate the trimmed mean. And then you remove 2 observations from the both sides and then you calculate the trimmed mean, right? Okay. So first you calculate trimmed mean, find trimmed mean by removing one observation each from both sides. And then again you find trimmed mean by removing 2 observations each. Okay, first you do those 2 things. Okay. And when you do that, you will have some value, right? Now what you have to do, you see that, okay, this number that you have 1. So 1 times alpha plus 2 times 1 minus alpha equals to what? Equals to 1.5. So you have to find the value of alpha. That what is this alpha value which is giving you this 1.5 value. Okay. So basically you have to see what alpha value will bring 1.5 here. So what should be the value of alpha here? If we want it to be 1.5, alpha should be 1 by 2, right?
Yes.
So basically when you do this, so this is alpha plus 2 minus 2 alpha equals to 1.5, right? So what you have, minus alpha plus 2 equals to 1.5. So you take alpha this side, 1.5 this side, you will get 0.5 equals to alpha, right? So alpha value is 0.5, right?
Yes, ma'am.
So what you have to do is put alpha weightage to this trimmed mean and alpha weightage to the trimmed mean that you got by removing 2. So let's say this was the mean. So trimmed mean that when you had removed 1, you have to multiply it by 0.5 plus the mean that you got when you removed 2 observations, then you multiply it by 5. Whatever that number comes up, that will be your 15% trimmed mean. Is that okay?
Oh, yes, ma'am.
Okay, we will do one example to do all of this properly, right? But again, reiterating this point, whenever you do some sort of trimming and this number this number is not an integer, then what do you have to do? You have to find an appropriate alpha value which will bring 1 and 2 equal to 1.5. So here I'm just using 1 and 2 because they were the example. It could be anything. So let's say, for example, if some sort of trimming comes out and you get a number 2.7. So 2.7 is between 2 and 3, right? So you have to find the alpha value which will bring 2 and 3 equals to 2.7, right? So you have to find that alpha value, and then again, whatever trimmed mean that you get by using 2 multiply by alpha plus trimmed mean that you get when you are removing 3 observation from both sides, and whatever that number is, that will be your whatever percent trimmed mean. Is that okay? ये करना
what we have to is equal to percentage of trimmed mean. I am not able to understand the last one after the equation.
Yeah, so like here you had a 15% trimmed mean, right?
Yes, ma'am.
So here, so when you do this, you will be getting a 15% trimmed mean.
Okay, ma'am.
And in this example, this was just some random example that I took. So let's say this was 26% trimmed mean. So whatever this answer will be, that will be your 26% trimmed mean. Let's take an example and solve it now. Okay, everything will become clear now after we solve it.
If we multiply that mean 2 by 1 minus alpha and mean 3 by alpha, then we'll get different answer.
You will not get a different answer, but you will then have to flip this. So if you want to use 1 minus alpha here, right? So then
Yes,
you
ma'am.
use 1 minus alpha here also.
Oh,
So
okay.
whatever you are using here, you have to follow the same thing. Okay.
Okay, ma'am.
So if you use 1 minus alpha here, same thing. If you use alpha here, then same thing. Same weights have to be given. Okay. So this is like finding a weighted average. Okay. All right. So, okay. Let's see. Trimmed mean. Okay. So let's take up an example now. And let's calculate. So this was one of the questions which came in the past years, but not the previous year batch, but before that. Okay. So let's do this problem and let's see. So let's see what is given to us. All right. So, the question is the marks of 21 students in a 50-mark mathematics test are given. So how many marks that students got in that 50 marks paper? 21 students gave this paper and their marks is given. Okay. And then you have to calculate a 10% trimmed mean for the above data. Okay. And for the sake of your convenience, all these data points are in what manner? Ascending order only, right? Okay.
Yes.
So you have to find 10% trimmed mean. Okay. So first of all, what you have to do, what is your n? 21. Okay. So, and we have to find 10% trimmed mean. So what is 10% of n?
2.1.
So 10% of 21 is 2.1. So is 2.1 an integer?
No.
Not an integer. So then what do we do? So this 2.1 is less than 2 and is it's greater than 2 and it is less than 3, right? So what do we have to do? First, we have to find trimmed mean by removing 2 observation, and then trimmed mean by removing 3 observations. Okay. And then we have to give appropriate weights to get the 10% trimmed mean, right? So if you do 2 times alpha plus 3 times 1 minus alpha, and you want it to be equal to 2.1, what do you have to do? What is the value of alpha? So 2 alpha plus 3 minus 3 alpha is equals to 2.1. So what is the value of alpha?
0.9.
0.9. So alpha is 0.9. So you have to give 0.9 weightage to the second like trimmed mean when you remove two observation, and 10% weightage to the mean that you get when you remove 3 observations, right? So this is the weight that you have. So first you find trimmed mean.
Ma'am, what did you say about the weightage now?
Yeah, so this is like when you give 90% weight to 2 and 10% weight to 3, you get 2.1, right?
Yes, ma'am.
So like this alpha 0.9 means what? I'm giving 90% weightage here and 10% weightage here, right?
Okay, ma'am.
Like that. So trimmed mean when you remove 2 observations from both sides. Then what is that? So you remove 2 observations everywhere. So what do you get? You have to remove this and you have to remove this, right? So what do you do now? You have to add all these numbers. So can you quickly add all these numbers for me?
Oh, sure, ma'am.
Okay, so basically आपको क्या add करना है? या फिर do one thing. Okay, fine. Yeah, just add all these numbers. Just add all these numbers. Okay. I will also do it side by side with you.
$655.
Yeah, I'm also getting 655. So what do you have? 655 divided by, so total there were 21 people. Now you have removed 4. What is left? 17, right? So if you divide that by 17, what do you get? You get 38.5294, right? Is that okay?
Yes.
Now you have to find trimmed mean when you remove 3 observation on each side, right? What would that be when you remove 3 observations? So basically you'll have to remove this and this as well. So from 655, you can just remove 25 and 45, right?
585.
Yeah, so you remove basically 60 and 70. So which is 585. And then you divide it by what? Earlier you had 17 observations, now you have 15 only. Because you removed 3 that side, 3 this side. So 6 are removed. So what is that? 39, right? So far, so good.
Yes, ma'am.
Okay, now what you have to do is you have to give this a weightage of 0.9 and this a weightage of 0.1, right? So, and then calculate the 10% trimmed mean. So what will be your 10% trimmed mean? 0.9 times 38.5294 plus 0.1 times 39. Whatever that is your 10% trimmed mean. Okay. So what is this now? 39. So this is anyways 3.9. And then this is 0.9 multiplied by 38.5294. So this is 34.67646. And then you add 3.9. So you should be getting 38.57646. Are you getting the same? This is your 10% trimmed mean. Okay. Can we calculate trimmed mean like now?
Yes, ma'am.
Any kind of trimmed mean. ठीक है? तो कैसे करना है trimmed mean? If that multiplication with your percentage and number of observation that is in an integer, then you clearly know how many observations you have to remove from each side. That is fine. So if this n would have been 20, we would have been fine. But now it's 21. So you find what is this between. So this is between 2 and 3. So first you find this trimmed mean by removing 2 each. And then this trimmed mean by removing 3 each. And then you try to give appropriate value, appropriate weight to 2 and 3 to get 2.1. And when you get that weight, you multiply the appropriate trimmed mean with that, and then you will get the required trimmed mean. Okay. Just do a little bit of practice for this. So it'll be fine after that. Is that all right? Can we do this? Any kind of trimmed mean question?
Yes.
Yes, ma'am.
Okay, perfect. Chalo. Now let's continue this question. Let's try to finish it up. Okay. The next question is also calculate the median. So how do you calculate median for this? There are 21 students. So what will be the median here?
11th
The
observation.
11th.
So 21, the 11th place, right? So what is the 11th place?
41.
3, 4, 5, 6, 7, 8, 9, 10, 11. So this is the median, 41, right? This is the median value. Okay, let's read it further. It was later discovered that the student whose marks were recorded as 35, a student whose marks were recorded as 35, this mark was not actually 35, it was actually 45. So how will this affect the median value? So question you understood, right?
Yes, ma'am.
So there was a student जिसके mark 35 थे. That student had a 35 marks, but later it was discovered that actually, sorry, it was a misprint. It was 45. So what will be the median value now?
Oh, ma'am, it will not affect the median.
Why?
Ma'am, 45. Okay, ma'am. That will.
So basically, what you have discovered actually, that in this ascending order, this position was not relevant, right? So instead of 35, now this 35 should not be here, and that person's score was 45. So there should have been just one more 45, right? Yes or no?
Yes, ma'am.
So now what is the median value? Again, the 11th position.
Yes, ma'am.
So what is the 11th position now? 1, 2, 3, 4, 5. This 35 is not there, okay? 6, 7, 8, 9, 10, and 11. So my number has changed, but actually the number was 41 only, right?
Yes, ma'am.
If here we would have 42, here we would have 42, then our median value would have changed, right? Because now it's the next number that is coming, right? So our 12th position is actually our median value now, right? Did we understand this?
Yes, ma'am.
Okay.
Yes.
So median is 41 only, but when we removed this, we actually moved from here to here. If they had a different number here, our median would have changed. Okay. So in this case, median will be the same. They have asked about median value. Median value remains the same. Median position changed for us, right? Okay, Ji. Is that all right?
Yes, ma'am.
Okay. So you will have questions of this sort. All right. So now we kind of have discussed everything which is related to measures of location. We have to do next measures of variability. So we will understand what is variance, standard deviation, range, and there is one important plot, which is box plot. We will do that. So that will be probably done in first half of the class, next class, and then we will do more and more problems. Okay. So yeah, all right, guys. Any doubts so far?
Ma'am, can we get the solutions of the readings somewhere? Is it available online?
So Devor solutions you are asking?
Yes, ma'am, the readings which we get from the college photocopy shop.
Okay. So there you only have the readings for Devor only, na? Or the Hog book is also attached?
I think it's only divorce, ma'am.
Okay, okay. So I'll check and I'll post it if it's available. Okay.
Okay, ma'am.
Okay.
Ma'am, in page number 20, there are some following aspects of the data.
Okay.
For example, identification of a typical or representative value, extent of spread. Could you please make us understand about these points?
Okay, let me check. Let me see.